recording. All right, so I'm gonna go over the assignment because we didn't really go over it there last week. So if you'll give me, I'm just getting everything going here, but please, while I'm digging for this, can you guys, I don't know, I hopefully everything is going all right. Last week there really wasn't much of a class, so I decided just to record it and away you go. And have you guys managed to look at the assignment? How is it all going? Does it look familiar?
Yeah, everything looks good there. Tash is on now.
Okay, she's in. That's good.
Yay. The assignment is due on Thursday, correct?
Yeah. It's due on Thursday, and your quiz is out now. I released it there last night. It's due next Thursday. And
So it is due. So is it due like at a certain time on Thursday, or by like midnight, or like 9 a.m.?
How I would like to do it is, I don't want to give you guys a complete smackdown. So the quiz, that has to be done before class, before the test, because next week there is no. Sorry, I'm just kind of digging through stuff here. Okay, so I've got that right there. Sorry, I'm coming. I'm gonna answer your question. I'm just getting this one right here and some bit final updated. Okay, very good. Okay, good. So now I'm ready to go. The assignment will be due at midnight, and the quiz will be due at 11. And I don't know if it, you know what I mean. Normally everything should be handed in before class, but the quiz, that one will close before the test, and you guys will have your. I'll open up the test there next week. There's no class. All right. So and you'll have enough time to do your test. Whether it's 3 hours or 4, I'm gonna give more than 3 hours because people have kids at home and I have kids at home and so I'm gonna give an extended amount of time to do the test, but the quiz should be uploaded before class. The assignment, I'll take it there anytime before midnight.
Awesome. Okay, thank you. And for the test, do we have like a set time that we have to start it by, like at 11 class time, or are you giving us a time frame?
I'm going to give you guys a time frame, and I hate. I don't know if you guys would know it by name, but it's called the forced completion, where as soon as you start the test, there's no stopping it. You've got to finish it, in the time. I don't really like that. I'll probably give you guys. I'll give you guys more than 3 hours, and you guys can stop the test and start the test because you know what I mean. We have kids at home. You know what I mean. There's no way you can concentrate with. I got a 7 and a 4-year-old. You know what I mean, and it's just mayhem. So totally flexible. You guys will be just fine, and I'll give you guys some more details there in the next couple days. But your test is done. It's honestly, if you do the assignment and you do the quiz, like, man, there's no reason why y'all can't get a hun on the test. So, you know what I mean? And the test has multiple choice and true and false and matching. And, this course is heavy on the definitions. So, matching will be good. And then, you know what I mean? Let's go over your assignment. Let's go over these, and that'll give you a little bit of an idea. Hopefully there you guys have had a chance to, I'm going to send out an announcement here, and you'll see that I've cleaned up some of these graphs because they were kind of, on my copy that I have, the graphs were kind of clear. One was shaded, one wasn't, but when I viewed your copy from Blackboard, it looked kind of fishy. So I cleaned it all up. So there's that. And then this one right here, just to give you guys a little bit of it's a lot cleaner. Okay. So with the assignment there, it kind of looks like mashed potatoes because you've got all these different questions and this and that all over the place. So what I did was what I got here now. Sorry. So what you got, just quickly, right here, you see I've cleaned this up and I've cleaned this one up here. So everything else is the same. Nothing has changed. I just kind of made it prettier and more user-friendly. And wherever you see a yellow highlight, that's a question there that I need answered. Okay, so that is in the way. So you'll see here, all these here. So you just go and answer the questions, yada, yada, yada. And there's space to put them in here. And I put these little reminders in on every single page. Please remember that only the last 2 pages are to be handed in or uploaded. Okay, so you can write whatever you want on these ones here. And then right here, this page here should be handed in with this information in here. And then all other questions can just go right in here. Whether it's true or false or multiple choice or whatever, or, if I'm looking for a number or ratio or percentage, y'all can just put your answers in here. So there's there's that. And oh, I need to reformat that, but I guess you guys can get that. So there we go. There's your assignment. And you'll see there everything there that we're covering. I posted there the week 3 PowerPoint there last week because we hadn't covered this yet, but hopefully there you guys have had a chance to have a look at it. We'll cover it there today. Is it difficult? No. All right, so this is where we're at. That's the assignment. And now where's my quiz? Week 3, yeah, it's in here, right? No. There we go. And there we go. And here's the quiz. So, and you see here, it's out of 47 marks and the following data. So what I've done is I've basically given you a tally or a frequency distribution, however you want it to. And you just, this here, we're dealing with a pie graph. So y'all are going to make a pie graph. Okay. And all the marks are here. These are half a mark each, and you come in here, do that one. Here you've got some data here. You're going to do a stem and leaf plot right here, answer some questions. Okay. Here I've got this right here, a cumulative relative frequency. Okay. You guys are going to make the columns. The heck was that, man? Whew. You guys are going to make the, we're going to learn something new there today called groups. Okay. And you guys are going to make a histogram and a frequency polygon and something called an ogive. Is it difficult? No. Not bad at all. We're just kind of, some things there might get a little confusing, but the questions there that I give you with the answers and all that, if you try a couple of those there, like we can go to, where is it here? My weekly folder. Right here. And you see, yeah. So you have your questions and your answers. They're all here. Everything there from the back of the book. You have all your questions. You have your answers. Everything is all here. And there's all your answers there for all the questions in the back of the book. And if you don't have it, then I've given you the questions. So they're all here. Okay? For goodness sakes, don't you dare try them all. That would just be silly. Okay? But do try some of them. Okay? And after today's lecture there, you'll see where you want to hit. Okay? So that's what's going on there for your quiz and your assignment. So your quiz and assignment are due there next week. Next week there is no class. There will only be, I'll open up the test at 11, and I'm thinking to give you guys, 5 or 6 or 7 hours or something. I don't know. That's what I'm thinking at right now. I'll let you guys know definitively. I don't know, sometime in the weekend, but hope you guys are doing well. Do you guys have any questions there for me? Talk to me. Anything there that's bothering you? Anything there that I can fix? Talk to me. If you guys are good, then I'll just shut up and I'll get moving. How does that sound? Yes? All right. Okay. You guys can hear me good, everything's good, then we're just going to get going, okay? The previous 2 weeks there, we've covered 1.1 and 1.2, and today we're going to finish off Chapter 1. Can you believe it? We're still on Chapter 1. But just the whole thing there with statistics is basically I'm going to give you mashed potato data. You know what I mean? It's chaos. Doesn't make any sense. You know, you guys are going to organize this data into some type of meaningful way. And then there's going to be questions about it. And I'm huge on these questions. Like generally the questions aren't, you know, the majority of the work is making a frequency table or, you know, calculations and all this kind of stuff, filling it all in. That's where a lot of the marks are going to be. But once all that is done, the most important part of statistics is to look at this organized data and what does it mean? What's happening in real life? Something societal, you know, and that's the whole point. So generally at the end of organizing data, there will be a couple of questions. And to me, that's the most important because there has to be some type of, you're doing all these tables and graphs and charts and this and that. Well, what are you doing it for? You're doing it to make society better. You know what I mean? You're trying to figure out if there is something going on in your data that is meaningful. Sometimes there's not. All right, but all right. So stem and leaf, tally chart, frequency tables. Those are kind of review, but we'll hit them again. Histogram, which is new, cumulative frequency distribution, and its curves, which is called an ogive. All right, and we'll hit a little bit of time series data and line graphs. Okay, because there is one on the assignment, I think. Yeah. So let's get on with this, shall we? And I don't even know how many of us there are. It looks like there's only 4. So there's 5 of us all together. That's right. So if you guys have a question, just shout out and let me know what's going on. So just to recall, discrete data is obtained by counting. Like cookies, counting people. You know what I mean? You're not measuring, you know, you're just counting, right? The number of people that walk into an ER room between 6 and 9 at night. Well, you don't, a little girl is one person just like a 7-foot tall adult. So there's no halves. So it's this is what we call discrete data. So in this kind of data here, there's no halves, there's no decimals. It's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, go on. Though that's what we're dealing with. So discrete is like counting cookies. All right. Continuous data. This is obtained by measuring. Okay. And like height, weight, you know, all these kind of temperature, all these kinds of things, right? And unlike discrete, that was 1, 2, 3, 4. Okay. Continuous data can have decimals and fractions. Okay. And there's 1.4 grams of a cookie, as opposed to over here 1.8 grams of a cookie. And you know what I mean? You could have 0.45 grams. So this is what we're talking about here. 2 kinds of data, and we're gonna talk about both there today. And I'm gonna try and make it as less confusing as possible. But for stem and leaf, hopefully there you guys are good to go on this. We'll do a little bit of review on, and we'll get all of this all going. I kind of do stem and leaf on an overkill, all right, because it's on the assignment, it's on the quiz. It'll be on the test. All right, so just the whole idea is you're taking mashed potatoes, and you have a look right here, and you're organizing it into kind of a graph. And I'm going to show you, this one right here. Or what do I got? No, I don't want that one. I want this one. This is all stem and leaf. You guys can have a, we'll come back to this. But you see, you've taken unorganized data, all right? And you've organized it. Now, how do you organize this? What you do is you take your data array here, and you will need to organize it from lowest to highest. You got to do it, okay? So we've taken this data and we've organized it there from highest to lowest. Now, you see these guys here, 33, 35, 38, and 39, we can actually put that into a column or a group because they all begin with 3s. All right, so here we've got 33, 35, 38, and 39. And then we take our other numbers, and in this case here we've only got numbers in the 40s. So here we go. And so this is very, very simplified, okay? But I think the point is that you've taken this mashed potatoes and now you've organized it. And you know what I mean? You look at it now, and what things does this tell you? Well, it tells me there that there are 8 data points. Okay? 1, 2, 3, 4, 5, 6, 7, 8. 35, 33, 35, 38, 39, 42, 43, 47, 48. It also tells me that 50% of the data is in the 3s, in the 30s. 50% is in the 40s. What's the lowest data point? 33, because you've organized it, right? You've organized it from lowest to highest. What's your highest, largest data point? 48. And you see, now you can actually start breaking these things down. Okay? I don't know. Did you guys have any questions specifically? I kind of like the fact that we only have 4 students, you know what I mean? I wish we had more, of course, but talk to me here. How are stem and leaf plots going? Are they okay? Are they pretty okay? Is there anything there that's bothering you guys?
All good for me.
You're okay? All right. If there's...
Yeah.
Hi, Nicole.
This is Natasha.
Oh, hi, Natasha.
Sorry, I sound awful, but
You sound great. You sound okay.
Thanks. I just wanted to make sure I do them properly. They're pretty easy, right? You just take the first number,
Right.
and then the second digit comes after in the leaf part.
You got it. So,
Okay.
and I'm going to, so you look at this one right here. The, just trying to find where that is here. Sorry for jumping around. But the whole idea is you're just lumping these basically by their first number value. And in this way, you see, like here we have the data regarding the number of prescriptions filled in each of the 15 hours that a certain pharmacy was open is collected at the end of the day and summarized in the following stem and leaf plot. Holy, that was long. But that's how these questions are. Because they're very wordy because they have to be very exact. It's saying one thing and one thing only. So anyway, you take your data here with mashed potatoes and you've organized it, right? And so you look at this one right here. We actually have a 0 here because here we're talking about the number of prescriptions in a 15-hour day. Well, one in a particular hour, only 6 prescriptions were filled, and in another hour, only 8 were filled. Well, there is no number in front of 6 and 8, so we'll put a 0. And now we're up into the tens. So here 10 prescriptions were filled in one hour, 11, 13, and 14. And you've arranged all these. And now you see that the nice thing is you've actually made a graph. If you kind of tilt your head 90 degrees and kind of look at it, you know what I mean? You've got yourself a little mini graph. And it's the crazy simplest way to figure out what's going on. So I wanted to show you guys here something like once you've organized this, now you can start asking questions. And to me, these are pretty important. Like, what is the total number of prescriptions filled over the course of a day? Well, you just add them all up, right? And every question will be different. But and any question there that I give you on a test or a quiz or whatever, it should be pretty good and but pretty straightforward. Like in this case here, there's 370 prescriptions. What is the highest and lowest number? Well, because these are all in order. Okay, the lowest number is 6 prescriptions. The highest number, there was 44 prescriptions filled in an hour. So, and there's a multitude of different questions, and you all can have a look at these if you feel like it, okay? I did wanted to show you there that when Natasha, was it Natalie? I'm just trying to think here. Was it Natasha? That's right. The if you're making a stem and leaf plot, this is not a stem and leaf plot. These are just kind of weird examples that I wanted to show you how you would input it into a stem and leaf plot. So if you have the number 38, how would you do that? Well, your stem would be 3, your leaf would be 8. Okay. Let's say you had 156. Well, in this case here, your stem would be 15 and your leaf would be 6. Okay, not bad. You guys can kind of see what's going on here. Just like we had there before, if you have a single digit like 8 or 6 or something, 0 goes in front of it. Okay. Even decimals are okay. You know what I mean? Let's say all of your answers are, in the 11.3 range. Well, then there you go. Your stem would be 11.3 and your leaf would be 6. So these aren't too bad. You know what I mean? Once you do 1 or 2 of them, it becomes kind of mundane. Okay, so as long as you do a couple of them there and you're good to go, I'm not too worried about stem and leaves. Okay, more information on stem and leaves. You know what I mean? You could just in this scenario right here, how many data points are we talking about? If this was a stem and leaf plot you just made, ignore all this, ignore. How many data points are on here? Well, you've got 36, 38. So there's 2, 41, 42, 47, 48. So there's another 4. 2 plus 4 is 6. And then we got 51, 54, 54, 55, 56. There's 5. So that's, what, 11? Okay, so there's 11 data points here. And it's very important that you recognize that. Okay, and if you have any issues with that, email me. We'll set up a time. We'll clear it up. Clear as mud. Even more stem and leaf if you feel like watching these videos. Okay, they are awesome. I've used them every year. I don't play them. Like if I was in class, I would play them, at least one of them anyway, but they're pretty, they're okay. So have a look at them if you need some more help, and if you need more help, get a hold of me. In a nutshell, stem and leaf plot provides a great visualization of the distribution of data. And part of the introduction, you know what I mean? We're taking mashed potatoes and we're making graphs. We're making organization out of them so that we can suck information out of this. You know what I mean? That's basically what we're doing. But one of the things there that we're going to focus on, not now, but soon, but I'm throwing terms at you there today, and hopefully 30 or 40% of them will stick against the wall there, and we can carry this in. And then when we really start doing this stuff there in about week 7 or 8, then you will recall. And one of the things here we're talking about is a distribution. You know, if I do a sample and I do a study and I interview these people and I get this data, and here's my graph, you know what I mean? Here's my graph. And what happens if all of my data is in and around a certain number? Well, then that tells me there that everyone who I polled or interviewed or whatever it was is kind of thinking the same thing, right? But let's say I do another poll and I interview another group of people there, and the data is all kind of spread out. Like, I've organized this data, but it's still kind of mashed potatoes. Aha. So here now, the spread of the data is very important. And we're sooner or later, we're going to be talking about the distribution of the data. In science, we would love all of our data to be right in here. Wow, we just asked 1,000 people the question, and they all came up with the same answer. Woo! This is the easiest PhD I've ever done. And it doesn't work like that. Generally, the data will have some type of spread. And it all depends. Maybe you're polling people in different neighborhoods, different languages, different ethnic minorities, all these kinds of things, and it's just interesting that not only is the answer important, it's the spread of the data. Because even different neighborhoods may have different views on different ideas. So what is happening here? And so we're going to start getting into something called the range. Okay? And but have a look here. Here I've got this mashed potato data. Okay, for whatever, you know what I mean. And we're going to organize it into this simple tally chart. So I've got 2 ones, so 1, I've got 2 here. I've got 1, 2, 3 2s. Okay. I have 3 3s and 1 4. Okay. So we've just made a little tally chart, which is in essence a frequency distribution. A frequency distribution will actually have another column where instead of having 2 slashes, I just have the number 2. And then for this one here, instead of having 3 slashes, the frequency distribution would actually have the number 3. So a frequency distribution is this thing here with an extra column. Okay, so, but let's look at this one right here. Here we've got a tally chart. Different from this one, but still a tally chart. All right. I want to show you guys here. So I've got 1 1, and I've got 1 for 3, and I've got 1 for 5, and I've got 2 for 6, and I've got 1 for 8. Okay, wonderful. Boy, it's just like the world's best. Look, I don't even have 1 for 7. I don't have 1 for 4. I don't have 1 for 2. And you look at this. Okay, I've done everything right. But it still looks like, is this really telling me anything? You know what I mean? Okay, I got 1 here, I got 1 here, I go, oh, here I got 2, and here I got 1. It's pretty spread out. Is there any type of relationship going on here between number 8 and number 1? Well, I don't really know. They're both the same, but they're pretty far apart. And you see, the problem is this right here is no good. No good. All right? And one of the things there that we want to do is we want to put this into groups. And when this isn't any good, all right, we're going to go and have a look at some groups here. So, as such, the situation requires the use of an interval of values, which we call a class. All right? And so you have a look here. The lowest number on the interval is called your LCL, which is your lower class limit. Okay? And the upper number on the interval is going to be your UCL, your upper class limit. And then there's another word here that we're going to talk about. It's called class width. Okay, so there's the class itself. There's something there that we're going to refer to as the lower class limit, LCL. There's your UCL. And then there's your class width. There's a couple things there that we'll talk about. But have a look here. And you see what we did? We had, instead of having 8 groups, you know what I mean, and signaling really nothing. Oh, you got 1, you got 1. Oh, you don't have any. What happened here? What we did was we broke these up into groups or classes. And they're exactly the same width. 1, 2, 3, 4. That's the first group. And then we've got 5, 6, 7, 8. So the class widths are the same. Okay. And you see now we actually kind of have something meaningful. I don't even know what we're talking about here. We're just counting, I don't know, apples, whatever. But you'll see here now that there is something kind of significant going on here. There's only 2 in the 1 to 4 group. That's interesting. And why is that interesting? Because in the 5 to 8 group, there's 4 here. So why is there 4 here and only 2 here? Now you're talking science. Now you're talking an investigation. Why did something happen? And you see, we didn't get that from here. Okay, you could look at it, you know what I mean? And okay, here's a group here, and here's another group here. You could do it with your eyes, and you could say that, yeah, it's kind of skewed over to this side. There's more here than there is here. But this is just pretty nicely done right here. Okay, so that's where we're at. All right. Now, I'm glad we're recording this here, and you may have to watch it a couple times. I'm going to go kind of slow on this stuff here. Is it difficult? No. Is it, are there some steps and some things to follow? Yeah. So, frequency and relative frequency distributions with class intervals. Okay. While there are no specific rules to determine the ideal class, we'll show you how to do it. All right. The class width should be a convenient counting number. You know what I mean? You don't want something obscure. It's got to be easy because if anyone else just picks up your table, your frequency distribution, all that, it should be nice and easy to see, visualize, understand. Okay, and where we're going, it will be. Generally, there should be between 5 and 20 classes. Okay, so even here, you know, we need more classes. Well, we really don't have a lot of data. Like, what do we got? 6 points. Okay, you know, where we're going to be dealing with you're going to be doing this, but I'm not going to give you 100 million points. I'll probably give you like 20, 25 points that you'll have to create your own groups and then put the points in, and that's how you'll do it. That's basically what we're on about. Okay, so you're looking at between 5 and 20 classes. There's a little formula or a rule that you got to follow, okay, to determine the number of classes. Because this formula here, it will tell you exactly how many classes you need for your set of data. So you got to use this little 2 to the k formula, okay? And the, what happened here? There we go. What's going on, man? Why is this doing this? There we go. Likes to jump around. Okay, so how do we use this formula to find out the number of groups? Okay, so let's just say, for example, why did that move again? There. Stop moving. Okay, so let's say we have 100 data points. Okay, for this one here, we got 100 points of data that we've got to try and configure. How are we going to get our groups? Well, you use this formula here, and what this formula means is 2 to the power of your groups has to be bigger than the number of data points. So we're looking at somewhere between 5 and 20. So if I punch in the number 5, the answer is 7 classes. I'm going to show you this. If I go 2 to the power 5, I'm going to get a number 32. Is 32 bigger than 100? No. I got to go up. Let's go to 2 to the power 6. That's equal to 64. Is that greater than 100 data points? No. Let's go to 2 to the power 7. That equals 128. That is now above 100 data points. So therefore, we use 7 classes. I'll do that again. If you have 100 data points, okay, using this formula here, you need to calculate a number that is bigger than 100 data points. Well, if I do 2 to the 1, that's 2, no good. 2 to the power 2, so for 2 groups there, that's 4, no good. 2 to the 3 is 8. 2 to the 4 is 16, still no good. 2 to the 5 is 32, no good. 2 to the 6, 64, no good. 2 to the 7, 128. Now we've reached a number that is greater than the number of data points that we have. So now we use 7 classes. Okay, hopefully that's as clear as mud. If it's not, shoot me, get a hold of me, man. We'll get her all done. Okay, so all data from the minimum value to the maximum value must fall into exactly one class. So you can't have a data point existing in 2 places. You can't have a data point that's not in a group. So all the data points there, they have to be in a group. Okay, so what we've got here now is you're going to have to figure out the range, but we'll get into that right now. So let's have a look here. The triage nurse at the ER record records the weight in kilograms of 24 patients seen during her shift as follows. So these are the weight in kg of 24 people who came into the ER. Okay, so construct a tally chart and a frequency distribution for this data. All right, let us go. So what we need to do, first thing, okay, when we're dealing with classes and groups here, first thing we got to do is we have to figure out the range. Okay? Highest number from lowest number. And however you want to do that, like generally there, you might want to put these into order. Okay, from lowest to highest. It generally helps. Time consuming, but you know what I mean. What's that going to take you? A minute? And you find your lowest number and your highest number and you subtract one from the other. So in this case here, the lowest number is 51.6 kg. Highest number is 123.2 kg. Subtract and you get, that is your range of values. So the lowest value is 51.6. Your highest value there is 123.2. All other data points fall within that range. Okay, and your range is 71.6. C'est bon? It's good. So you got your range. Now you figure out your K. All right? Now you figure out your number of groups. Well, 2K has to be greater than or equal to N. So N will be 24 because you got 24 data points, right? Now you would need to figure out what K value is going to give you a number just above 24. So if we go 2 to the 1, that's 2. 2 to the power 1 is 2. 2 to the power 2 is 4. 2 to the power 3 is 8. 2 to the power 4 is 16. Oh, we're getting close. 2 to the power 5 is 32. That's the next one there that is over 24. So we are going to have 5 groups. How's that? And I kind of explained it down here. 2 to the 4 is 16, not big enough. Need to hit 24. 2 to the 5 is equal to 32. There we go. So we'll have 5 groups. Okay. So what we've done there, we calculated the range of the data, and we figured out the number of groups. Okay. Now, what do we got here now? That's good. Okay. Now, we need to find the width of each group. Take your range, divide it by the number of groups. So this is step 3, because it says step 3. Okay. And once you divide the range by the K value, the number of groups, you get this number here. And for this particular example, it's 14.32. You always round up. I know in normal mathematics there, 14.32, you would round down to 14, right? We can't do that here. That's not what we're rounding up. We have to encompass all the data points. So whatever number gets kicked out here, you round it up to the next full number. So you see your class widths will be 15. Okay? So that's step 3. Range. Okay, find your groups. Find your class width. All right. Now we're on to the LCL and the UCL. Okay? Now what's my lowest number going to be? What's my highest number? And this is where we start to figure out the intricate details of each group, which is not difficult. So your lowest number there is 51.6, so it just kind of makes sense. You make your LCL 50, right? Make it a nice even number, nice to see, nice to view. People like round numbers. There you go. So you set your first LCL to the minimum value in the data set, okay? So just below the minimum value. So if we have 51.6, start it up at 50, okay? So the minimum value is 51.6, and since the data is continuous, the lowest class will be 50. Okay. Discrete data will be a little different. We'll get into that. So now, what we have our range, we have our number of groups, we have our class width. Now we have a starting point, right? It was 50. Okay. And if you look at this data here, we're dealing with what? Weight, right? In kg. What kind of data is this? Discrete? Are we counting? Or is it continuous? Are we measuring? It's continuous, right? So there can't be any gaps. No gaps at all. All right? This is continuous data. You know what I mean? 14.3, 14.4, 14.5, 14.6. It's all continuous. So we start off with our 50. Okay? That's our LCL. There will be 50. The next one will be 50 plus 15, right? Because that's our class width. 50 plus 15, so 65. And then you add 15 to that one. And then you add 15 to that one. And then you add 15 to that one. So there we go. There's our 5 LCLs. If I'm going too fast, talk to me. All right. Now, because this is continuous data, we're measuring. There can't be any gaps. Okay? I want to show you this better. And you see what we do. There's your 50, 65, 80, 95, 110, right? We already did that. Those are our LCLs. Now, because this is continuous data, no gaps at all. 50, and then, it's 15 is the class width, right? So 50 to 65, but for continuous data, we have to use under. So 50 to under 65. So not 65, but under it. So 64.999999999999999 is still in this class. 65 is not in this class. It's in this class. To everything under 80. And 80 is here. You see how this one works here? This is for continuous data. So that's what this is blah, blah, blah and all about. Okay? If you're using discrete data, counting the number of people that came into an emergency room. Okay? You don't get half people. You only get 1s and 2s and 3s. So that's discrete. Okay? Have a look at this way of making groups. 0 to 9 would be my first group. 10 to 19. 20 to 29. And nice and easy peasy. But what do you notice here? There ain't nothing in between 9 and 10. There's nothing in between 19 and 20. There's nothing in between, because we don't count half people. There will never be, this is what discrete means, okay? It means there's no flow, it's very distinct, right? So numbers you'll have from 0 to 9 people in this group. And then if you have 10 to 19 will be in this group. So that's how things work if it's a discrete, okay? But right now we're just looking at continuous, okay? So now there's the, what was it, the 6 steps. And again, you don't have to memorize this. You know, I forget, is it on the quiz there you got to make it, or maybe it's on the test? But yeah, you'll have to do something like this, okay? And you don't have to memorize it. It's right here. If I'm asking you to make groups, well then okay, go to the week 3 PowerPoint. There we go. Step 1, step 2, step 3. Okay, easy peasy. Oops, did I just say that? All right. So that's what we're talking about there. That's how you make these groups there for continuous data. And I've shown you there a little bit there about discrete. Okay, so, and now you've got some nice groups. You've got some nice data. And now we can do some things with it here. We can do some graphing. So once you've done this, now let's get on and let's move on to different stuff here. So for graphs of frequency distribution of quantitative data, unlike qualitative, the horizontal axis usually represents a continuous number line. Continuous, no gaps. Recall there the class limit is a frequency distribution. The class limits in the frequency distribution are the upper and lower data values. Okay. For discrete data, there are apparent gaps. Remember we talked about that? There was no number between 9 and 10 because we don't count half people, right? Okay, so that's how these ones work. This is a good little slide. It just kind of gives you examples. Okay, so for continuous data measuring. Okay, have a look at these here. The class boundaries are the same as the class limits. So your class interval, 0 to under 10, 10 to under 20, 20 to under 30. Those are my class intervals. But your class boundaries, you have a look here. If I look at this one right here, what are my boundaries? 10 to under 20. Well, 10 is a boundary, right? 10 is in there. It's a boundary. That's the end of the fence. But let's go to the upper, to under 20. 20 isn't a boundary because you can 19.9, 19.99, 19.999, 99999. You can keep going to infinity and never hit 20. You see that? And it's kind of like the idea that there is an infinite amount, and this may blow your mind. So if I don't want to blow your mind is okay. Explode your mind I don't want to do. But there are an infinite amount of numbers in the universe, right? 1 million, 1 billion, 100 billion. You keep going, just add another 0, and now you've got an infinite amount of numbers. But if you have a look, how many numbers are between 3 and 4? And you're probably thinking, what do you mean, how many numbers are there between 3 and 4? Well, there's 3.1, 3.2, 3.3, 3.399, 3.39999, 3.339999999. There's an infinite amount of numbers between every number. Talk to me if I just exploded your mind here. But this is what we're talking about here. In these guys here, there's only one boundary. In this example here, 0 is the only boundary. In this one here, 10 is the only boundary. Okay? But for these ones here, we're going to change things up here. There's your class interval, 0 to 9, 10 to 19. Okay? And you have a look here at the gap. The gap between these groups or classes is 1. Okay? So for these ones here, for discrete, our boundaries are 0.5 in between. So 9.5 would be a bottom or top for this group. Okay? 9.5 would be the bottom for this group. 19.5 would be the top, the boundary for this group. 19.5 would be the bottom for this one. Don't worry if it's kind of confusing you. It's all right. We're going to hit this there a couple times there before the end of class anyway, so you guys will be fine. So just have a look at that. That's a good little slide there, okay? And why are we doing all this? Finding the midpoint of all these guys here, because we need to make a histogram and these guys here. So frequency polygon, but we'll show you guys all these here. So for continuous data measuring, okay, the class intervals 0 to under 10, 10 to under 20, 20 to under 30. The class midpoints would be 5, 15, 25, 35. 0 to under 10, what's my midpoint? 5. 10 to 20, what's my midpoint? 15. 20 to 30, midpoint 25. So that's for continuous measuring data. It'll all come together here. I'm just throwing stuff at you here. Apologies. For discrete data, remember counting, there's gaps, all right, because we don't count half people, all right? 0 to 9, what's my halfway between 0 and 9? 4.5. 10 to 19, what's my half there? 14.5. 20 to 29, my halfway is 24.5. Why are we doing all this? Good. And you see what we've done here, if I keep hitting this thing, is now we have our class intervals, our class boundaries, and our class midpoints. Am I going to ask you to provide all these? No. But you will have to show me something here when we get into a histogram. And I'll show you these. They're not too bad. So a histogram is a specific type of vertical bar chart that is used to visually represent the summary data from a frequency distribution. Okay? And you'll see here that unlike bar charts for qualitative data, there's no space here because this is continuous. There's no gaps. 20 to under 30, which is touching. 30 to under 40, which is touching 40. You see how this one works, okay? The class intervals are marked on the horizontal axis, and the class frequencies from your frequency distribution are up on the left. Okay, so that's how a histogram works. A frequency polygon, woof, this one here is just, it's killer. You have a dot in the middle of each of these, and you connect them. All right. Please note that the dots should start and finish on the 0 line. Okay? Not too bad there at all. So there's 2 bananas there. There's your histo and there's your frequency polygon there. Okay? Histogram and frequency polygon, they kind of go hand in hand. If I'm asking for one, I'm going to ask for the other because you've already made the one. Okay? Outliers. I'm not going to go crazy on anything outliers right now. We will come to them. And I'm going to blow this up here. I'm going to do a little bit of a 5-minute rant about where we're going. Okay, and I'm going to move that over here. Okay, so you have a look here at this distribution. And, okay, histogram, frequency polygon for income distribution. I don't care what it's about. This is about how much money people are making. Okay, whatever. And, you know, however many people we interviewed or asked or whatever it is. But I want you guys to start looking at these graphs with, you know, what is this graph telling me? And you look at this here. Where is the majority of the data? Well, what is this thing? Well, you go to the highest one right here. Well, here, this is most people in this poll are making between 50 and 75,000 or under 75,000, right? Okay, so that's a good focus point. And now let's say that maybe half the people, you know what I mean, they're making from 25 to 100,000. That's generally where most of the people are. So that gives you an idea of what people are making out there, or at least half the people anyway, right? You're trying to take anything from these. And yeah, and then, but you see how these frequency distribution, like this is, it's kind of showing you a visual representation of a frequency distribution. And, if your graph looks something like this, sorry, I'm just trying to get in there, like this. Well, most of your data is in here. Well, that's important stuff because that's the majority of the population. Okay, great. That gives me an idea. But what's going on out here? These outliers. All right? And generally, they're not as important because we are more concerned with the masses of people rather than the sparse few. But if you were, let's say, a craft beer producer or some small little business who's making something, maybe you're making cat pillows, well, I don't know, out of fake fur or something like this, and they're just very specific. They're only for cats and people who love cats, and maybe that's your niche market. You're not looking for where everyone else is because maybe the majority of people don't like cats. You're going to target the rich and expensive cat lovers who like to pamper their cats, which are more the oddity than the normal, right? So maybe as from a business perspective, you're looking at the outliers. Because if you have, if this is the population of Canada, there's 35 million people in this graph. And maybe, and this is an outlier over here, but maybe that represents 750,000 households. Well, for me, from a small-time business venture, I could really do with 750,000 sales. So it all depends on your marketing strategy. It all depends on what you're looking for. And but we'll get more into outliers and more into this population curve. We'll get in there. We're getting there. So that's what I'm just introducing outliers here. Am I really going to kick the can on outliers there for the test? No, but we will get there. Okay, so the outliers are important. Not so much there for this test. Okay. You remember there your tally chart. I'm just trying to find an old version of a version there that I wanted to see with a tally chart and a frequency distribution. Okay, so anyway, here we go. Here's your number and your tally. You'll have your frequency distribution here, which is just the numbers here. You'll have another column, which is called your relative frequency. Okay, your relative frequency, and which is just percentage, right? And then you'll have another column, which is called your cumulative frequency, and then there will be another one there called your relative cumulative frequency. And I'll show you these right now. Are they difficult? Nada. So, where are we here? Okay, so what we've got here is you've got your classes, which you know how to make now. Okay, try a couple there. There's too many questions there for you guys to do in the review questions. So do a couple. They become pretty cake. Okay, and here's your frequency. These are the numbers that fall into each of these categories. Your cumulative frequency is you are accumulating as you go, right? You pick up a stone, put it in your pocket. You keep walking, you pick up another 2 stones, put it in your pocket. How many do you have now? 3. You keep walking, you pick up 4 stones now. Now you've got 7. You're accumulating more as you go down the chart. That's all this is. So your frequency here, I had 2 in here, I had 4 in here, I had 8 in here, and 11 in here, 8 in here, 4 in here, 5 in here, and 2 in here, and 4 here. Or 40 total. Well, as you're going down your cumulative frequency, you start off with 2. They're the same. But now, as you're going along, you're gathering stones. 2 plus 4 is 6. 6 plus 8 is 14. 14 plus 11 is 25. Okay, and all these guys. I'll show you here. There's another one. and it's called your relative cumulative frequency. You can have a relative frequency in here, which is just your percentage, which is 2 divided by 40. What does that give you? 5%. So you'd have a 5%, which is the same over here. Okay? But your relative cumulative frequency now, because you have your total, 2 divided by 40, it's 5%. 6 divided by 40 is 0.15, which is 15%. And that's how you figure these guys out. Okay? Any questions on that one? Because on the test or the quiz, I think you'll see one column, you'll see your class interval column, you'll see a frequency column, you'll see a relative frequency column, you'll see a cumulative frequency column, and you'll see a relative cumulative frequency column. You will see all of these, okay? But are they difficult? They're not that bad. If you have any questions, talk to me, okay? Now, you're thinking, why? This is all new. This cumulative frequency and relative, this is new stuff, okay? And there's a reason. And we use cumulative and relative cumulative frequency for a histogram. We use it for, an ogive, which I'll show you. And you'll see here. Now, what we've done here is you take these numbers here, your cumulative frequency, and you take these numbers right here. And we make a chart. And you'll see here at 40 there was 2. And then at 50, there was 6. Okay? At 40, there was 2. 50, there was 6. 60, there is 14. 70, there is 25. And you're gathering the stones as you go so that this thing better finish on 100%. And what this is, you're just taking these numbers here, okay? And you're putting them in here. There's your 40, your 50, your 60, your 70, your 80. Okay, there's your class intervals. Here's your cumulative frequencies, all right? And that's how these ones go. This is called an ogive, okay? The cumulative frequency of class 50 to under 60, which is 14. And we can go right back here. 50 to under 60 is 14. Okay? Is plotted against the 60. So there's your 60 and there's 14 right there. And that's how these ones go. And that's called an ogive. It's just an accumulative way of looking at the graph. And now, you see, you can your relative cumulative frequencies, okay, you see that one there, which you took from here. Now you can see where half the data is. Well, half the data is right here. All right? What's going on here? And you see there, you can just look at it and start analyzing this. So try these out, okay? Just to let you know, though, okay, that for, you will have a total column at the bottom. For it's under here. The total there will help you there for frequency. You'll have a total of 40. That's your total. Please notice that your cumulative frequency, that number there, better match that number there. 10 times out of 10. If it doesn't, you've got a problem. You've got to go back and there's a mathematical error in there somewhere. So that number, it's got to equal that one. And this number here, it better equal 100. Okay? Has to equal it. So just 2 fail safes there. So you guys can check and make sure that you guys are on the right track. Okay? Time series data, these are pretty cake. Okay? Like here we've got systolic and diastolic pressure of a patient that we've measured over a 10-day period. Okay? So day 1, the systolic pressure, the BP was, or the blood pressure was 165 over 100. They measured it again, 160 over 94, which is actually recommended. You walk into the doctor's office, you never know what your BP is going to be, because it all depends on what you had there that day, how much stress. In order to get a proper idea of what your BP is, you should do it over a couple of days span anyway and get an average. Okay? So we've got over a 10-day period. So this is what we call a time series data and line graph. Okay, and here we have two different bananas here to analyze, but you could have one different. You could just measure systolic and have your own graph on that, or you could just measure diastolic. Or because we're dealing with the same time frame, you might as well throw them both on, which I think is on the assignment. Okay, there's an assignment there. That's kind of like that. Okay, and yeah, this is what the assignment looks like there. Please remember, whenever you are making a graph, okay, and you'll be making it from scratch. I think on the test, the assignments, and the quiz, I just give you an empty graph. Okay, you've got to have a title. Okay, you've got to have units on this side, and you got to tell me what's happening. And here we've got blood pressure in millimeters of mercury. Perfect. I got units, and here I got days. Okay, and because we have two graphs on here of the same, or not the same, but two graphs on here, we need to color code them. Okay, so here's my systolic, here's my diastolic, and you can see what's happening here. Okay, so these are time series graphs. They're not so bad. Okay, you can analyze these until the cows come home, but please make sure that your graphs are labeled. Okay, and there's a bit of review, but this is where we're at, and I got nothing else. Do you guys have any questions for me? Because maybe some of the stuff there a little confusing, but go and try some of these there, and they really shouldn't be that bad. Your assignment is due in a week. Your quiz is due in a week, so you have lots of time to fiddle around and to practice these. Advice: do not do your quiz until you've done week 3. Okay, which means read the PowerPoint, seen the video, tried some of the questions in the back, read the chapter, you know what I mean? And then, do the quiz there next Wednesday or something, it'll be open. So you have time, everything should be okay. Talk to me. I'm going to stop recording, and that will